10 agents. 30 minutes. The report came back marked complete. 4 domains. Untouched. The coordinator never defined the jobs. 1, 2 to 4, or 10 plus. The scaling rule. Welcome to AI Tech Book, Atlas Exam Prep for the Claude Certified Architect, Domain 1, 27% of the exam. Today, task decomposition. How a coordinator turns one goal into scope subagent tasks, and why getting that step wrong is the most expensive mistake in multi-agent systems. Every team that ships a multi-agent system eventually hits the same wall. The coordinator returns a confident report, comprehensive, well-written, thorough. Then a domain expert reads it and finds the gap. An entire category missing. The subagents ran perfectly. The planning was wrong. 2 coordinators, same 10 agents, same subagent prompts. One produces complete coverage. The other produces confident-sounding gaps. The difference isn't capability. The difference is that one coordinator described the goal and the other decomposed it. Decomposition turns a goal into a task list. Delegation specs turn each task into an isolated executable unit. Both steps happen before the first subagent fires. The teams that skip them ship systems that work in demos and fail on production inputs with novel structure they didn't anticipate. This episode covers the 3-tier scaling rule, the 4-part delegation spec, context packing, task ordering, and the 2 failure modes that appear on the CCA-F exam every time. How many agents should a coordinator spawn? Most teams answer, as many as possible, and then discover that 10 agents running the same 3 searches costs 15 times the tokens, with no additional insight. Here is the rule Anthropic embedded directly in the coordinator system prompt. Simple fact finding, 1 agent with 3 to 10 tool calls. A direct lookup, no parallelism needed. Direct comparisons, 2 to 4 subagents, 10 to 15 tool calls each. Different facets investigated in parallel. Each subagent goes deeper on its assigned facet than one agent going wide could. Complex research, 10 or more subagents with clearly divided responsibilities. Each one owns a distinct domain. No overlap. This is a commitment level, not a headcount. The tier sets the tool call budget for each subagent, not just how many to spawn. And here is the architectural detail the exam tests. These rules are in the coordinator system prompt. Not hard-coded, not in application logic. The coordinator reads the rule and applies it at runtime, per query, using extended thinking to assess complexity before spawning anything. Change the scaling policy, edit one prompt. A coordinator spawns 3 subagents with a shared goal and no further specification. The first 2 investigate the same time period. The third interprets the goal differently and returns a summary in a format the coordinator can't synthesize. None of them had bad instructions. None of them had any instructions. This is not a subagent problem. This is a missing specification problem. Each subagent needs 4 things to succeed in complete isolation. Field 1, the objective. What exactly defined? Not just a topic, a specific question the subagent's output must answer. Field 2, the output format, the shape of the return. If the coordinator expects a structured summary with 3 sections and gets 5 paragraphs, synthesis requires an extra normalization pass, more latency, more cost. Field 3, tool guidance. Which tools to use and at what depth? A subagent given no tool guidance will choose its own budget. Sometimes that's fine. On a tight token budget, it's not. Field 4, scope boundaries. What is not this subagent's job? The explicit exclusion that prevents 2 adjacent subagents from overlapping on the shared edge of their domains. The 4th field is the one teams most often skip. Without it, 2 subagents researching adjacent topics will overlap on the boundary. The exclusion is the partition between them. The spec is the decomposition made concrete. Here is the CCA-F exam scenario that trips almost everyone. A coordinator decomposes AI impact on creative industries into 3 subtasks: AI in digital art, AI in graphic design, AI in photography. The subagents run. They each do excellent work. The coordinator synthesizes a polished final report. The report covers only visual art. Entire domains, music, film writing, for example, are untouched. The subagents didn't fail. The coordinator's decomposition didn't cover the goal. Here's why this happens and how to catch it before you spawn. Subagents execute in isolated context. They get nothing from the coordinator automatically. Every piece of information a subagent needs must be explicitly packed into the task prompt, or it doesn't exist. The freshness test. Write the task prompt. Then ask, can a completely fresh Claude model with only this prompt and only these tools produce the correct answer? If yes, the spec is complete. If no, something's missing. For large background artifacts, use just-in-time context. Pass a file path, not the file. Pass a search query, not the results. The subagent loads what it needs at runtime. Packing 50,000 tokens of background into a delegation prompt uses the subagent's entire context window before it starts the actual task. 30 seconds on the freshness test catches an entire class of wrong but confident outputs. 2 subagents launch in parallel. The first returns a summary the second one needed. The second completes with half the information it should have had. No error is thrown. The output is plausible but incomplete. This is not an execution failure. This is a task ordering failure. Draw the tasks as nodes. Add a directed edge from task A to task B if task B needs task A's output. Any node with no incoming edges can start immediately. Run these in parallel. Nodes with incoming edges must wait. This is the dependency graph, and it is part of decomposition, not just spawning. Most research tasks are parallel. Sequential dependencies usually appear only at the synthesis layer. All domain research runs in parallel. One coordinator synthesizes at the end. That means the total wall clock time is the duration of the longest parallel task plus the synthesis pass, not the sum of all tasks. Ordering is a correctness property. Wrong ordering produces wrong answers. Not slow answers, wrong ones. 2 failure classes dominate production multi-agent systems. Both are invisible until a domain expert reads the output. Both are diagnosed at the coordinator's decomposition. First, overlap. 2 subagents with intersecting scope. They investigate the same material, run the same searches, return summaries the coordinator must deduplicate. Cost doubles. Coverage doesn't improve. Fix. Tighter task boundaries, the 4th field of the delegation spec. Second, gap. A domain within the goal has no subagent assigned to it. Subagents complete their tasks correctly. The report is incomplete. Fix. Check the task list against the goal's full domain before spawning. The coverage audit. Together, MECE. Mutually exclusive, collectively exhaustive. A good decomposition satisfies both. Overlap violates the first. Gap violates the second. The CCA-F exam test, given a coordinator's task list and the original goal, identify whether any pair has overlapping scope or whether any domain is absent. The answer is always a coordinator side fix. Never use better subagents. Decomposition failure is the dominant coordinator failure mode. Fix the planning. The subagents are fine. Thank you for watching. Subscribe to AI TechBook to catch the next one. Coming up, when subagents duplicate work and overspawn, the orchestration fix.